Okay, we're going to take a look at some trig graphs today. If you think of tangent as being sine over cosine, um, well, I guess you were supposed to have memorized some of your tangent stuff. We could also go from there. You should know that the tangent of 0 is 0, that the tangent of 45 is 1, tangent of 30 was root 3 over 3, the approximation is about here, tangent of 60 is about right here, and then you know that the tangent at 90 is undefined, that's a vertical asymptote. If we would try and use your calculator like tangent of 80, you would be way up here. And then you know that your tangent when you go negative angles like negative 30 degrees is negative root 3 over 3, tangent of 45, negative 45 is negative 1, and so on. So if you plot those tangent values, you would get this shape. Now, it actually does continue up here, get close to your asymptote, does continue down, get close to your asymptote. So just be aware of that. Also, your tangent graph would repeat. In this case, tangent goes from negative 90 to 90, which is 180, and you also know from your unit circle that it repeats every 180 degrees. And so this is what your tangent graph looks like. And your period would be 180. Or if you're dealing with radians, you know it would be pi. You need to be familiar with the way your tangent graph is going to look like because you're going to have to deal with that when you are doing assessments, so just be aware of that. We're also going to go ahead and look at secant. And so if we do the reciprocal of cosine, down below I have my cosine graph drawn in with dots. Now, if we do our reciprocal, here we're at a height of 1, because you know the cosine of 0 is 1. Reciprocal of 1 is 1. Over here, we know at 60 degrees, cosine of 60 degrees, you know, is 1/2. Reciprocal of that, you know, is 2. If we do the reciprocal of root 2 over 2 for our 45, we're here. Similar if you're dealing with these over here. When you're at negative 60 degrees, that's 1/2. Reciprocal of that is 2. Do your reciprocal here of negative 45, you're here. When you go ahead and plot a few more points, you would get stuff along here. And some of these you're going to have to go ahead and they're not on your unit circle that you're supposed to have memorized, so you'd want to go ahead and do decimal approximations. When we do the negative part right here, reciprocal of -1 is -1. Reciprocal of, let's see, that would be 135. That would then be down here because that would be negative root 2 over 2. Here, if we're at 120, reciprocal of, which is 1/2, reciprocal of that would be -2. And keep doing that, we would have all these shapes. So if we draw these in, we actually get these shapes. Now, this whole, whoops, sorry, not what I wanted. This whole first part here is referred to as one period. I drew part of another period. When you actually draw these, you need to draw at least one full period. Now, you know the period of cosine is 360, or 2 pi if you're dealing with radians. So its reciprocal function follows that also. You can also see that we started at negative 90, went all the way to 270, which is 360 degrees. So when we're looking at our cosecant, you know, is reciprocal of sine. If we plot those values, it'd be very similar to what we were just doing. Reciprocal of 1, reciprocal of 1/2, you know, is 2. And so we could just keep doing our reciprocals of all these sine values on here. and you end up getting the same shape, just moved over a little bit, which should make sense because the sine and the cosine graphs are really just the exact same shape, just slid over a little bit. So if you go ahead and connect all these dots, uh, not what I wanted. There we go. We get these horseshoe shapes. Horseshoe up and horseshoe down. It's a horseshoe down whenever your sign was negative. It's a horseshoe up whenever your sign was positive. Now, if we go from here to here, this is one full period, which goes from 0 to 360, so you know your period would be 360 degrees. Now, notice with your secant and cosecant graphs that we do have these asymptotes, but we also have a bottom of the U and top of the U here. So bottom of the U here is at a height of 1. Top of the U here is at -1. Same idea back here. It's at 1 and at -1 as you see here. So just be aware that those values are important, which happen to line up with the number that's in front here. So let's look at what happens when we're dealing with a sine or a cosine graph, and we put numbers in front of either the angle or numbers in front of the trig function. You should remember earlier in this course that if you put a number in front of a function, it does a vertical stretch. Now, if you want to use your graphing calculator, you're more than welcome to. I would encourage you to. Type in sine of x in your y2. Type in y equals 3 sine of x. Then, before you hit graph, I would go zoom down to trig. If you go zoom down to trig and then hit graph, you'll see that the second one has a vertical stretch of 3. It goes 3 times as high and 3 times as low. How far up and down you go from the x-axis we call amplitude, so in this case we would have an amplitude of 3. Now go back and put into your y equals, still your sine of x, but put a 1/2 in front and then graph it, and you'll see there it only goes up a half and goes down a half, so your amplitude is a half. So what happens then if you don't put the numbers in front of the whole trig function, but just in front of your angle? In that case, if you type that in, you'll see that it does a horizontal stretch, which affects the length of your period. It's a horizontal stretch of 1/3. Your original period was 360 or 2 pi. It's going to be 1/3 of that. So in this case, we get 2 pi over 3. If you put a 1/2 in front and graph that, you'll have a horizontal stretch that's twice as much. So your period, instead of being 360 or 2 pi, it would be double that. So in general, if you put a number in front, it does a vertical stretch, which affects your amplitude. Your amplitude's always positive, so it's absolute value. Because if this was a negative in front, it would have the same amplitude, but it would flip your graph upside down. The number in front of x we refer to as b. That does a horizontal stretch, which affects your period. And so you get your period to be 360 divided by b, or if you're working backwards because you know your period, you need to find b. It's b is equal to 360 over your period. Now, if you're dealing with radians, you'd want to be using 2 pi instead of 360. So this graph over here is not a simple graph, but what we need to find here isn't too bad. We need to find our amplitude. To find that, we need to identify our maximum. Well, here's your maximum right here, which would be at 8, and your minimum, which would be right here, which is -4. So we'd plug in our max and min, work that out, and we get an amplitude of 6. Now, your midline down here is also related to max and min. So we'll do that next. We'll go our max, which was 8, plus our min, divide by 2, and we get 2 is your midline. Well, y equals 2 because midline is a line. So if we draw in our midline, we get y is equal to 2. Now notice your amplitude up here, right here, is how far up and down you went from your midline. You went up 6 and you went down 6. So your amplitude's how far up and down you go from that midline. Now period is how far you have to go before you start to repeat. Well, if I just start drawing this out, I start here, I go up, come down, and then I'm going up and down again, but you notice this second dip is not the same as the dip I just had, so I got to keep going. But now it starts to repeat again. So this would be the same as what I just had in blue. So the period would be how far you go on the blue or how far you go on the green. So I would say it starts at 0, goes just beyond 6, so I'd say it's around like 6.2. Frequency is always just the reciprocal of your period, so it'd be 1 over that, which is approximately 0.16. So here we want to find our amplitude and our period. Amplitude is always related to what's in front, so there's nothing in front, there's a 1 there, so our amplitude is 1, so you'll go 1 up and 1 down. Now, what's in front of your angle affects your period. So it's going to make it, instead of 1/3, it's actually 3 times as big. So your period was 2 pi, so it ends up being 6 pi. So what I would do is I would start out by just drawing your basic sine graph. By the way, I would go ahead and make 4 evenly spaced tick marks here. I would make a tick mark going up and a tick mark going down. Then I would come along and sine starts out at the origin, and so then at the 4th tick mark you got to start back at that same height. Halfway in between, you're at that same height. In between these first 2 red ones is where you're going to be at the top point. So halfway in between, which is here, I got to be at that top point, which I marked over here. In between the second 2 red points, I got to be halfway in between, and that's going to be my bottom point, so this has to match over here. Then I would draw in my basic sine curve. Now notice this is a curve, it's not sawtooth mountains or anything like this. Now that I have my basic sine curve drawn in, I would then come along and start putting my labels on these tick marks. My amplitude was 1, I go up 1, and I go down 1. My period was 6 pi, so 1 full period goes all the way to this last red mark, so that's got to be my 6 pi. Then this one right here has got to be halfway in between, which is 3 pi. So go ahead and draw your basic curve first, and then put your tick marks on later. So here, what's in front, the absolute value of that, is your amplitude. So you're going to go 1/3 of a unit up and 1/3 of a unit down. What's in front of your angle affects your period. B is 1, so your period is not affected. So once again, I would start off by going ahead and putting 4 evenly spaced tick marks on your x-axis. And then I would do a tick mark on how far up I want to go, and then how far up I go has to match how far down I go. Then once again, with sine, and we're dealing with sine, you start at the origin, and then on your 4th tick mark, you got to end up back at that same height. And then halfway in between those two, you got to be at that height again. Halfway in between the first two, you got to be at your top. Halfway in between the second two, you got to be at the bottom. And then do a rough sketch of your sine curve, going and drawing it in there. Now, we had set up here, we have to go up and down a third. So I know that this is going to be marked as a third. This would be negative 1/3. This one right here would be 1 full period, which is our 2 pi. So we'll mark that as 2 pi. This is halfway between 0 and 2 pi, so that is pi. So why don't you see if you can quickly do these, finding your amplitude and your period. So here we get an amplitude of 2. We have a b value here, so it's going to be 2 pi over b, so we get 8 pi. Over here we get an amplitude of 3 because that's what's in front. We have a 2 in front, so it's going to be 2 pi over 2. It's only going to be half as long, so it's pi. Now, when you're dealing with your cosine graph, you still go ahead and do your 4 tick marks. And then you got to do a tick mark up and a tick mark down. How far up you go, how far down you go, they have to match. Now, when you're looking at cosine, which we are here, cosine starts out at the top. So right when x is 0, you got to start at the top. So then above your 4 tick mark, you got to end up there. Halfway in between these two red dots, which is here, that's where you're at that bottom tick mark, which has to match with this mark over here. In between the first two is where you cross your axes. In between the last two is where you cross your axes. And then you draw in your rough sketch of your curve. So then you go ahead and you say, well, this is 1 full period. Our period is 8 pi. So I put 8 pi here. This is halfway in between. Half of 8 pi would be 4 pi. If you wanted to put these in between here, you can. You don't have to. In between, halfway in between 4 pi and 8 pi is 6 pi. Or halfway in between 4 pi and 0 is 2 pi. How far up and down we go is our amplitude, which is 2. So I'm going to mark this as a 2 up here, if I can get to it. And then this will be my negative 2 down below. Same type of thing over here. You start out by doing your tick marks, 4 evenly spaced tick marks. And then you go up a certain distance, and whatever distance you go up, you got to go down that distance. Once again, with cosine, you start at the top, and you, above the 4th one, you end at the top. The middle one here, that's where you're at that bottom. It's got to match this height here. Halfway in between these two is where you cross. Halfway in between these two is where you cross. So then you draw it in. This 4th one has to be where your period is, which we know is pi according to this here. So then this would be half pi. How far up you go has to be your amplitude of 3. And your opposite of your amplitude, which would be negative 3. So that's 3. And this would be negative 3.